Hello guys, today we are going to talk about how to find a count of sets of numbers which can add up to a result. Now let's take an example. Let's take an example of a integer array. Okay, 1, 15, 8, 13 and 5. And the final result which we want is s is equal to 28. Now, if you look at this array, there are two sets of numbers which can add up to 28. One is 15 plus 13 and second is 15 plus 8 plus 5. So there are two sets of numbers which can add up to the value 28. Now let's see how we are going to do it in a programmatical way. In a programmatical way, we have to find all the possible combination and find out which one of the combination which will add up to 28. So we can start from either left or right. Let's start from the right. So let's take the number 5. 5 has two choices or two possibilities. One is a set with 5 and second is a set without 5. So I'll write down both of them. And next one, let's add 13 into the mix. Once we add 13 into the mix, we have four choices or four combinations. First is a set with this empty set. Second is a set with 13, and third is a set with 5, and fourth is a set with 5 and 13. Now let's take the next example and let's add 8 into the mix. Once we add 8 into the mix, there will be 8 combinations. Let me write down a little bit of it, part of it. So we have a combination of 8. Then we have when we have a set of 13. Then we have a set of 13 and 8. Then we have a set of 5 and 8. Just 5. Then we have a set of 5 and 8, and so on. And then we have a set of 5 and 13 and 8, and then a set of 5 and 13. So if you look at this, the number of sets will increase by twice every iteration. So the next one, once we add 15 into the picture, the number of sets will increase to 16, and once we add 1 to it, the number of sets will be increased to 32. So so in this way we can figure out which all sets will add up to 28. Now for the simplicity of implementation, we are not going to store the set in the memory. Instead, we are only going to store the remainder. So for example, the remainder value of for this empty set will be 28. So for the remainder value for 5 will be 28 minus 5, which will be 23. For remainder value for 13, it will be 28 minus 13, it will be 15. The remainder value of 5 again will be 23, and the remainder value of 5 and 13 will be 5 plus 13 is 18, and the remainder value is 10. The moment the remainder value becomes 0, that means we have the match. That means the numbers in the set will sum to 28. Now let's see how we are going to implement in Java. So let's write a recursive function, public int. So static int count matching sets. So we need 3 parameters. One is integer array, and we need an int reminder, and then we need the index. So this index is this index denotes which index we are doing the processing. The moment the index become less than 0, that means we can stop. So there are three possibilities where we can stop the processing. I will write down one by one. If reminder is equal to 0, that means we have a match. So that means we have a match and we will return 1. If if the reminder is less than 0, that means we then all the if you combine all the numbers in the set, it is more than the target result. So that means it is return 0. And if index is less than 0, that means also we return 0. Okay, so with this we have find all the initial validation. Then we will look into, the next possibility is, what if the array of index is less than or is greater than, instead is greater than the remainder. So if the array of index is greater than the remainder, then we cannot have a set with that value. So that means we are going to do a recursive call with the array without the current index, that is, the remainder will remain the same, and then index -1. Otherwise, we have two possibilities. We can have a set with the current index and without the current index. So without the current index, this will be the call, plus without the index, with the index, that means we will remove the will subtract the current index from the remainder, that is array index. Okay, so we'll enter return. Okay, so that will take care of the whole that will take care of finding the number of sets which will add to the target result. So let's print out the total count. It will be, okay, let me write it down, integer array. Let's copy paste this value. Okay, array. The remainder is always 28. This is the target amount we are looking for, and the index is array dot length -1. Okay, now let's run this too. So that is what we got the result. But if you look at the time complexity of this algorithm, so every time a number is added to the array, the complexity is doubled. That means we are looking for the complexity of 2 raised to n. So now how can improve the time complexity of this algorithm? So the best method is to use a dynamic programming. A dynamic programming is nothing but memorizing the results. If you look at this array, that value 13 is exists in both the sets, both places, in here and in the first iteration and second iteration. Also 5 and 13. 5 and 13 will also exist in the third iteration. So if you remember these values, what is a reminder? Or we can say, if we can store these values, then we don't need to calculate every time. So in order to do that, we will create a hash map. Okay, a string, int, integer, cache, new hash. Okay, and we use this cache to process it, to store the intermediate results. So we'll use this value to store this intermediate results. Okay, and now okay, and we will pass the cache every time. Okay, now before processing any of the result, we have to first check whether this cache the data in the cache exists. So for that, if cache contains key, so before that we have to create a key. So a key is a combination of the remainder plus the index. So string key equals remainder plus index. Okay, so cache contains key, which is key. If it contains key, then we will immediately return back. We don't need to process anymore. We can return back, return so also also in addition to that, we have to store the results every time we calculate it, so that we can return back. We can return back. So instead of returning immediately, what we do is we will int result is equal to this one, and then we store this cache dot put key and result, and then return the result. Okay, so along with that, in the same method, if we return instead of int result cache put and result, I'll just copy paste it. Okay, so in this way we are storing all the intermediate values, and we can improve the performance of this algorithm. So let's run one more time. Yeah, so this algorithm is a combination of recursion plus dynamic programming. With this we are concluding this session. Thank you guys.